In this video, we'll focus on multiplying polynomials, and we'll have three different methods that we'll talk about as to how we can do this. So the first one we will talk about is what I refer to as the double distributive property. And this method here is the one that we will use if we're talking about more than binomials, which is usually what we end up talking about is binomials, but on the off chance that we're not, that's the method that I usually recommend, and we can expand that to trinomials. Then the other two that we'll talk about that are usually pretty closely related, we'll have FOIL, or sometimes I call it the smiley guy. So we'll talk about these methods in this video, and we'll talk about the uses for each. These bottom two are for when we're talking about binomials only, and we'll talk about what that means here in a second. So let's start this out with an example. We'll talk about the double distributive property first. That's the one where it makes the most sense to talk about first. So before we get to this example, I want to kind of go off to the side here, and let's say I wanted to take 3 plus 1, in parentheses, times 4 plus 2. Well, in our minds, we know that this is the same thing as 4 times 6. If we were to follow our order of operations, we add the 3 and the 1 to make the 4, we add the 4 and the 2 to make the 6. We should ultimately get 24. Now, let's think about this a different way. If I was to go through this, we could say this is the same thing as 3 times 6 plus 1 times 6. Now, you might be asking yourself, okay, why would you do that? The whole reason is that if I'm looking at this example over here, I can't combine this stuff in the parentheses. So I'm trying to think of another way that we could potentially do this. So back to our example here. I could rewrite this 6 as 3 times 4 plus 2 if I wanted to. And then similarly, I can do plus 1 times 4 plus 2. And then I can distribute to make 12 plus 6 plus 4 plus 2, which if I simplify, I get 18 plus 6, which we know that will get us 24. So this method works, and in particular, this is the line that's going to be most beneficial to us. So if we're looking at this expression now, we can look at this as, okay, we have x plus 2 times x plus 1. So I could look at this as we have x times x plus 1 plus 2 more times x plus 1. And if we use our knowledge from the last lesson, multiplying monomials times polynomials, we can distribute here. So we're going to get x squared plus x plus 2x plus 2, which we can then simplify to x squared plus 3x plus 2. Now, if we're doing this for real, you can just go ahead and jump to this step. You can break apart the first expression, the first binomial, and multiply it times the second binomial. Distribute, combine like terms, and then simplify. This is how we do the double distributive method. Now, another method that is quite popular in most textbooks is called the FOIL method. And FOIL is an acronym. So each of the letters stands for a word. So F is for first, O is for outside, I is for inside, and L is for last. So if we're looking at this, what it's trying to tell me, and I'll circle this one in blue for starters, I'm going to multiply my first terms. So I get x squared. Then I'm going to multiply my outside terms, which we'll do that in red. So I'm looking at the outside two, the outermost, so x and 1 in this case gets me just 1x. I'm going to do the inside terms, so I get 2x. And then I'm going to do last terms, which gets me a positive 2. So that would result in x squared plus 2 plus 2x plus x, which, if you remember from the last example, I get x squared plus 3x plus 2, which is the same thing we had before. Now, I don't usually call it FOIL, I call it smiley guy. So if you look at x plus 2 times x plus 1, you can just say, okay, here's the mouth, there's the chin, eyebrow, eyebrow. And you just do the multiplication of all those terms and still do this combination. However you like to think about it is fine, just whichever method works for you. Between FOIL, smiley guy, double distributive, all of them are totally valid methods, and it does not matter to me which one you use. So at the beginning of the video, I mentioned that FOIL and smiley guy don't work if you're not talking about binomials. However, double distributive does. So if we're looking at this trinomial example, and the trinomial means three terms, which would be this expression right here, the first one, the x squared plus x plus 1. I can't use those two methods that we just talked about, the smiley guy and the FOIL, because, well, the metaphor kind of loses its meaning. So the whole idea is that I'm going to take 2x times this, and I'm going to take 1 times this. And then if I was multiplying two trinomials, then I would take each individual piece of one trinomial and multiply it times the whole other trinomial. So in essence, what I'll have is I'll have 2x times x squared plus x plus 1. And then I'm going to have another, so 1 times x squared plus x plus 1. Now, it would definitely matter if this number wasn't a 1. It's going to change some things. So in essence, we could probably drop the multiplication in this case because it's a 1, but I just wanted to show you where it's coming from. So if we continue with this example, we'll distribute in on all of these. So I'm going to have 2x cubed plus 2x squared plus 2x. Distribute these in, and I'll have plus x squared plus x plus 1. And now I'm going to go through and I'm going to look at like terms. This is the only cubic term, so I'm going to have a 2x cubed ultimately when I'm done here. Now I'm going to go through any other x squareds, which there are 2. So I have 2x squared plus 1x squared. That makes 3x squared. And then I have 2x terms, so I have 2x plus 1x makes it 3x. And that is my only constant term, so it'll be a 1. So ultimately, if I do this multiplication with this trinomial, I get 2x cubed plus 3x squared plus 3x plus 1. Now remember, those different powers on the x's, I can't combine them with addition and subtraction, so this is as good as it gets until I know what x is. Now this is an example of how you use double distributive property, or I guess in this case, well, I guess it would still be double, but you could have triple distributive. You're basically expanding the distributive property to be whatever you need it to be. Usually we will only see binomials, but I do want to make you aware of these trinomial cases as they do pop up from time to time.